Labguy here. In this video I'm going to give you a report on the ferrite vector deflection yoke that I'm building. At this point the first axis winding is completed and this coil is ready for testing. Let's look at some video of how we got to this point. I'm sitting here talking, trying to avoid starting this because this is going to take at least an hour, and clearly I'm not going to create an hour-long video of me doing this. I wouldn't do that to you guys. So let's get started to put on the second half of the first pair of coils on this. And already off to a ripping start. I need my eyeballs. And I guess I want the high magnification. I do. Okay, here we go. Okay, that's the old winding. The new winding is bound. Okay. These first few turns are kind of critical to get the cadence of the windings. They have to be packed close together, but not overlapping. All right. I have this down to somewhat of a science now. Okay, and we just start doing this. I have to release a half turn every 3 passes of the ruler through the core, as the circumference around this ring is 3 inches. So every 3 to 4 passes consumes 12 inches of wire, roughly. And here we go. The astute viewer has noticed that I have a red rubber band on one end and a blue rubber band on the other. Not that it matters much. Now when I do this, I pull and put tension on my wire and I hold everything together. I don't want these loops of wire on the ruler to fall off while I'm doing this. That would be a catastrophe. There we go. And then I turn the ruler and pull it taut and loop it through for the next pass. And the complete half winding, or 180 degrees on the core, is approximately 165 turns according to the calculator. but I don't know for sure. I'm going by the length of wire and the resistance, which is, what is it, 2.4 ohms. So when I parallel these two windings, they should be about 1.2 ohms total resistance. Alright, and we do it again. Okay. Oh boy. Somehow. Shoot. We're there. Just not opening up any more room. Okay. Okay, that's pretty much it. That's our coil. Wow. Okay. That's a lot of work. Okay. There we go. I'm going to wrap some Kapton tape around it. I'll have the wires sticking up this way, and when I do the other windings I'll have the wires sticking out the other way. This is the same kind of tape they wrap the Mars rovers in. It's called Kapton. Uh-oh. There we go. It's half a deflection coil. Maybe it's half a deflection coil. So, after over 3 hours of winding wire on the ferrite core, this is the result. This is one of 2 coils that will be wound on here. You can see the wires sticking up. Now in theory, if our wires are here on the side this way, our magnetic field will go across this way and bend the beam up and down. So let's grab our M1234 P31 CRT and hook up the test system and give this a try. Pardon the shakiness while I shoot handheld. Here's the CRT. I've positioned the yoke with the coil wires oriented this way so that the field should generate a vertical up and down if it works. I've connected the electron gun once again to my ICO regulated high voltage power supply and to my Labguy very high voltage power supply. We've set that for about 2 kilovolts. It's connected to the second anode of the CRT. The heater in the tube, I don't know if you can see it, the heater is already on. And so the first thing is to turn on the first anode, which is running at 150 volts. Our grid one is running at minus about 40 volts right now to keep the beam cut off. Okay, the signal generator is set and is running at about 40 cycles per second. So we turn on our high voltage, and I'm going to put you here so you can see the CRT, and I'm going to turn the G1 bias so that the beam comes on. And what do you know? Our deflection yoke works. I'm not going to reach over and grab that tube, but not with power on. So we can change the scanning frequency until we get a straight line. Or we can turn it up abruptly. And we got it moving real slow. Now that's plus and minus 200 milliamps of current. We're getting about 1 inch of deflection. So this yoke is going to require a couple of amps of current. It's not unusual and not impossible. So here we are at high speed, very high speed. That's about 200 cycles per second. And we have a line. And you can see that line rotate if I rotate the yoke. Well, you could see it if my hand wasn't in the way. So we can move it around that way. When I add a second winding, we'll get a second axis. I'll turn that brightness up. So, the first axis of the deflection yoke works. This concludes my report on the development of the toroidal vector deflection yoke thus far. In the next video, we'll demonstrate the yoke with 2 axes. I am personally expecting some geometric distortion from this yoke, but time will tell. Welcome to all the new subscribers. Greetings to all the current subscribers. You guys rock. Keep coming back and watching these videos, because I promise you I'm doing things on YouTube that nobody else is doing. Greetings to Arcade Jason, who gave me the inspiration to wind this deflection yoke. And until next time, Labguy out.